to any questions? Everyone's worn out from the assignment, or you're looking forward to the storm tomorrow, or low blood sugar. So did we talk about, I don't think we talked about the mediator pattern last time, did we? The last time was...
Something else.
Yeah.
We stopped on hinge last time.
But the mediator comes before the hinge, so I'm not sure why I skipped over it. Yeah, so the mediator is what the English word implies, right? Someone sort of coordinates interaction with a bunch of objects. And the goal is if you have a bunch of objects that interact with each other, then the interactions can get complicated together. You get n objects, right? There's n squared different combinations of. Whereas the log to mediator, right, that should be n squared, can be just n. Which does simplify connections. Right, and the structure is pretty simple, but you have a mediator. And usually a bunch of concrete collaborators that interact with the mediator. Right, so basically, the interface, concrete mediator, there's a coordination, conversation between the concrete colleagues, and then each colleague talks to the mediator to get his job done. And again, the colleague is a role that something's going to play in your system. So like if you're going to start seeing colleague A, colleague B, colleague C in your system, it's going to be they'll have the roles that implies what they do as opposed to the role they play as a competitor. Now you might call mediator and mediator just for communication purposes, let people know, okay, this is what this guy, this object is involved in coordinating things. Right? But you'd probably give it not just mediator, but what type, what's it mediating? And so the most example is this dialog box. So you were elected to come to class. Now they pay you, per assignment.
Plus they're all standing out there. They need to go somewhere. Some other summations.
So they'll stand outside to make sure you actually turned it in, right?
Yeah.
And once you walk in, they can go away and trust, right? Now, if they paid you, then maybe they could have left earlier, right? They pay you half before, half after, then. So the problem that mediator patterns finding examples that people can relate to and understand what's going on. And that's one reason why I leave it to the end, like, how do I explain how it works and give examples? I think, well, let's go back to this. So here is a dialog box for selecting fonts. And so there's several things here. One is there's default names or sort of default types, small, large, etc. So you select one, it then has to show you the current value, and it shows you an example of that font. And then we can select a font to replace that, so it shows you this. And then, of course, there's different, bold, etc., different sizes. And some fonts, not all fonts support all sizes, right? So when you select here, it changes the legal values here, and it changes this text, and this looks like, and it changes what this looks like. When you click on this button, it's going to change the default value, right? So there's a lot of interaction between these parts. And so then how do you organize all the interaction, right? So for one, we could, when we select this list, we could have it directly talk to, right, the size box, and we directly talk to this, and directly talk to that. So what you want to do instead is you just tell the mediator, okay, here is the current selected font, right? And then the mediator has to say, okay, that means, now I talk to that component, I talk to that component, I talk to that component. When I click on this button, right, I tell the mediator, okay, user's now selected current font, right? So the button doesn't have to know that actual font name, doesn't have to interact with any of this. It just tells the mediator, right? Makes sense.
It seems like there's some similarity and overlap between this and what we looked at with ReactiveX and that, and then also with this and Model View Controller, and then even the way that the pattern is drawn reminds me of client server. So is there, are there just are there semantic distinctions between all these things, or?
Well, yeah. So the question is, we start to see similarities, right? On client server, well, anytime, again, a client is anything that makes a request, right? And a server is anything that makes answers a request. So when you say client server, you're talking about a network situation where the client's here and the server's over there, right? And so we send a request. We can also use the same terminology in object, and every time an object calls a method on another one, the first object is the client, and the one we're calling on is the server to give the answer. So in that context, right, that mediator tends to be more like a server, right?
That's in the diagram. You
Right.
get the one central, and then like the other ones all look just like clients. If you got a database server, everyone's kind of mediated
Right.
by the database server.
But it is slightly different, right? Because in the database server example, I mean, usually what you do is either you're sending data to the server, right? You're either new data or modified data, and then people make requests, right? So in that case, the server is really passive. I mean, it sits there, you say, here's new data, so I store it. That's all I do, right? Or you get a request saying, give me list of all employees. Okay, and that's what I do. But here it's like, okay, when the user selects on a font, right? Then the mediator is going to say, okay, that means I have to do these three things and update this, and change that.
Yeah, I guess because the arrows go in both directions.
Yeah. Yeah.
So if it's got a push model, though, then it reminds me more of ReactiveX and observer pattern, where that would be the subject, and then those are all the observers.
Right. Now that on the observer pattern, right, it's like, oh, I've changed, now you figure out how I've changed, right? And so then we push out to the observers trying to figure out what they need to know on what I've changed. But here it's more hardwired. Okay, I selected, right, the default fonts. Now I need to look up, sometimes look at what the default font really is, right, and then update it. As opposed to saying, I've changed, and then my list has to look up, okay, what's changeable here? Right, so the
logic is way more contained in the mediator
Yes.
versus distributed.
Right, right. The goal here is, right, on the observer pattern, the goal is to make the subject as less coupled to the observers as possible. Right? Here the goal is to make all the constituents, right, independent of each other. But now the mediator is highly coupled to that situation, right?
Mm-hmm.
That font selector dialog box, I mean, that's all it does, and, right, no one pretends it's going to do anything else, right? There's no, look, if I do it this way, I can reuse the code. No, it's a very concrete situation. It's like fonts here, I mean, everything to do with fonts. And then we can go back to this, right? And we can then clearly that the mediator has to know a lot about the interacting, right? It has to know when I figure out a new name font, then I have to pop up a window so you type in the name of the font and that's added to this list, right? But it's not managing the list. When someone selects on the list, right, the mediator is not involved in finding what the selection is, right? The selection notifies the mediator, okay, here's what's happening. So we don't want to pull all the logic into the mediator. We want those constituents to do some of the work. It's just that, oh, when I press on this, we have to add something here. Well, when I select one of these fonts, right, that has to update this option and this option. So I think that's another reason why I pushed it in, is because if you and then say, oh, I've got a God class, no, that's a mediator.
So what's your definition of a God class?
Well, the definition is easy. The hard part is to identify it, right? A God class is the opposite of a struct, right? The struct is like, okay, we have a class and there's no operations, just getting sets. That means we're doing the work somewhere else, right? And often all that work will accumulate in one place. So this one class is doing actually all the work, and the other classes are just structs. And the problem is in that God class has to know how everything works.
As does the mediator.
Yeah, right.
But then hopefully the mediator's programming to interfaces and not knowing too much into details about,
How the constituents actually work.
Yeah.
Yeah.
And is there usually an interface on the mediator, or are all the other guys just calling methods on them?
The pattern talks about having an interface to the mediator, so that gets, even there it gets complicated. It's like, yeah, but if, in this example, how many times are you going to do that? So then you've got this interface, well, your interface on one ever implementation of it is like a slippery slope, right?
And it seems more important to have good interfaces for the stuff it's talking to.
Right.
And hopefully they don't call too many things directly on the mediator at all. It'd be nice if the mediator is more saying you do this, you do this, you do this, not the other way around.
No, but the problem is, like in this example, right, what happens when, when I select this pixel small, I mean, this has to update, and that has to update, and that has to update, and that has to update, right?
Okay.
And either we hardwire that list to do it automatically, or we tell a mediator, look, the selected name font is changed.
Yeah. But it's still minimal, because you're just saying, hey,
We're not trying to
update.
Yeah,
You're not telling the mediator, hey, I changed my font, so go put this over there.
You're saying this change happened, but that change implies that we do all this stuff, right?
So then when you show the reactive X and like Swift examples, I think, where automatically it does all this stuff,
Right.
and the mediator is built into the system.
No, yeah, so the question now is how the mediator pattern interact with reactive X. And,
Well, specifically for those UI examples that you showed us, where it was very integrated.
So there, what happens is, looking at a Swift example, you have the data object, right? And then when you modify that data, when you have a data object, you say, well, this text field gets this data, but from that part of the data field, right? And this list view of all these things is, comes from this collection of things. And now to change the value in the text field, we don't go to the text field at all. We just say, you modify basically the model, what we call the observed state object, and say, here's the new text. And automatically that will propagate through the updating the text field. Now the difference is, it's just a one-to-one mapping, right? So the string here in my state, and that string maps over to this text field. This collection maps to this list. And you modify this list, you modify it, and it updates that one, or possibly other places, but wherever that text is displayed. So it's not like here where I select a particular item and then bing, 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 other things have to happen. And to do this in that setting, we have a list, and then we have when you select it, we have to then have the GUI basically have another state variable say, look, here's the selected index, right? And then we have to have other views that are dependent upon that index to do the right thing. So it changes a little bit. I'm just thinking about how I would implement this in Swift UI. And then all the dependencies sort of get pushed to, you've got your state objects. Basically it's, you need this list, you need a list of fonts, and you need various text fields, and you need a variable for what item is currently selected. So when you select it, the GUI would change that state variable, and then this view would depend upon that be updated based upon that selection. Definitely lead to a slightly different implementation. It's also a much newer idea. Directed functional programming started like 1999, and even then it took a while to build up. Whereas, right, the Gang of Four book was published in '95, which means those ideas were late '80s, early '90s, and just worked right up. So we're definitely seeing change in how you build, how you organize software since the Gang of Four textbook came out. Any other questions?
Have you seen the code samples for this one?
Okay. You wouldn't do any good as also.
It's hard to imagine like how interaction like a push and pull. I mean, every subscriber is pushing a state, and then at the same time it pull it. So little bit code would be helpful to understand it more way.
With the language, I mean, you'd find the language a bit hard to follow. So now I think we've covered all 20 patterns, right?
That was it for Mediator?
What else do you want?
I don't know, more examples. But Mediator is one of those patterns that can be scaled and applied to larger systems, right?
Yeah, but again, it's hard to imagine the scale, it's harder to imagine a bigger scale. And then there's a mediator of the facade.
Well, it kind of reminds me when we were talking about serverless
Right.
systems. Rather than having everyone talk to everyone, you could have Mediator, which would then be kind of like a server again, except that it would push and pull instead
Right.
of just.
Right.
And then Mediator could have a facade, so that the other guys can know how to talk to.
I think in serverless, I think the database becomes the ultimate server, right? If you're not doing data, then it's hard to, I mean, why you, I mean, what your system for, right? And you need to save it so that you can get it back again. And it might be you can partition your data into completely separate disjoint sets. And so it's all fake, right? I mean, it's a worry about when something happens and you talk to here, talk to here, talk to here. Right, so we're going to create special buttons. We have buttons, default buttons, which tell us something happened, and then we mediators. Okay, the button was pressed, so now what do we do? It's like okay button, like, can a button write it? And the button knows what should happen. Whereas here it's just, okay, I click on the button tells mediator, right, I was pressed.
Now that example now looks like a controller.
Right, yeah. Yeah.
So in the model view controller, the controller is kind of the mediator.
Yeah, we'll get to that pattern. Originally in the model view controller, the controller handled the input. So it was, when there's a mouse event or keyboard event, that would first go to the controller would be, okay, who gets this event? The model of the view. Which part of the view would go to the model? And since then the controller has morphed into other things, those lines. Right, so in the first example, okay, button does work and it knows what the text fields, whereas in the example, the button, the login dialog knows about the text fields. So the components don't have to know about, the button has to know about the password and the not all cases can do this.
So in that example, that reminds me of, I forget what it's called, but in the observer pattern, there's that manager that kind of makes sure everything's efficient. And you know what I'm talking about? I forget what they call it in the game before, but there's an optional component in the observer pattern that sort of coordinates everything. For example, keeping a cyclic graphs to make sure that things aren't getting updated more than they need to be. And
yeah, and also perhaps doing things with the threads. Yeah, again, we keep on coming across ideas that are repeating, right? Or in some form or another.
I don't think they call that a mediator. I wish I could remember what they call it.
Yeah, I don't recall.
Something like that.
For some reason we talked about the solid light, right? So now you can claim that you know all 23 gang of 4 patterns. So when you go to a job interview, it's like, oh yeah, I know all the patterns, I know all 23. And let's see. Log the meter. And yeah, hinges, right? The analogy here is that our software, the point from what our software to be flexible, right? We need to be able to, it has to adhere, it has to be easy to change. Not necessarily everywhere, because it's flexible change everywhere, because it's too hard to, it becomes too cumbersome to make that happen. And for me, when we're learning software, there are a couple of things that we sort of hide in universities. One is most applications deal with data, right? And so in some form we have a database behind the application. And how does that change how the application is built? The other one is this. When we write software for business, which is, writing software for business is a big business, right? What does ServiceNow do? Well, they write software that business can use, right? No company is writing software for. And the finance industry, the whole thing is driven by software, so they've got tons of programmers writing software for business to use to. And these days you go to Starbucks, right? And it used to be there was a cash register and there was like they press in the amount, right? $12.13. Now to do the latte with cream and sugar, right? The big panel that displays, the products they sell, and no longer need to do the arithmetic, right? Because you press the buttons, right? It's a latte, it's muffin, it's this and that, and then it tells you how much it is. $13.12, right? But then what happens when Starbucks wants to have a special, right? We're going to have a special. It's Thanksgiving, and so pumpkin. We want pumpkin spice coffee, right? We want pumpkin spice this, or all these things, or maybe you want a Good Friday discount to bring people in off the screen, and all that has to go. It's no longer, here's, you print out a menu for that day, and then go to the next cash register, and they type in it. They're still typing, they're pressing on now there's got to be a button for pumpkin spice coffee, right? And how do we write software to allow people to change these business rules basically overnight?
This is always, I think it's a huge aspect of design, because on the one hand, you kind of want your software to be an engine where its behavior is driven by data.
Mm-hmm.
But if you take that too far, you just reinvented the programming language.
Right.
And so the amount of data that people have to provide to make something do anything is,
Yeah.
So it's hard to find that balance, but it's definitely good to get it right.
But if you come from a Java background, right? How do you do this? Right? Forget about getting the balance right. I mean, how do you even do it, right? How do you write the software so that we're that flexible?
And I'm doing something now in another class in Java where I'm pulling, data from an XML file and drawing dialog boxes and stuff from the data that I pull.
Right.
So the general form is defined by the application, but then the actual specifics of what's being shown is in XML files.
How would you do that?
Well, and that's where it's tempting to then make your XML format more expressive.
Right.
But then, once again, you're now building a programming language when you already have one. But plugins might work for that.
But it may, what that is could change next week, right? Maybe, every week, right, your manager wants some special deal to draw people in.
So over here, interceptor pattern would be helpful. Like we have our own domain long language where we're saying this is the policies, and we create our own classes like to understand these ones.
Yeah, but if we're creating classes, how do we create the class overnight to make it work?
No, I'm not saying to create a classes. The language which we created, like we created a set of classes.
Mm-hmm.
All are interceptor pattern. I'm just saying. So whenever we say give a policy,
Mm-hmm.
that policy can be converted into a domain language which is understood by our classes. We do not need to implement the classes right away. We have a set of classes which understand the policies. If a very unknown policy gonna come, unknown kind of a thing, that's a different case. But it's gonna capture whatever they have already seen in the past, like that kind of a policy. That makes sense.
Yeah, it also has to be driven by the data, right? I mean, somehow we need to specify, you know, that in data so that whether it's XML or some other format, right? I mean, there has to be some. And so for a while back, there was a paper written that tried to explain how to do these things. There's one way, using metadata and active objects. Now, on the side, metaprogramming like this is why this early on was almost universally used in AI. Because in this program was this data. Right, it's a bunch of parentheses and things in it, right? And so literally, when you look at the data structures, again, it was lists with parentheses. So it's easy to write programs which manipulate your own program or other programs. So writing self-modifying code, this was natural. And Java happened. Things changed. So these papers talk about, you know, software evolves, right? We keep on. What tends to happen is you try and make things more and more general to handle more cases, right? Rather than having more and more code, like, oh, can we make a general case like this, and then, you know, push those details into the data so we read it, right? And okay, now here's how we're going to draw. Here's all the diagrams we're going to draw, right? Instead of fixing the diagrams, or the schema changes, and our program reads the schema, so it knows how to, right? So if we're actually going to do this, right, then the things have to change at runtime. Read the data and have to figure out, right, what to do with it. So there is what they call the property pattern. And so at some point, objects may need to have more state than they did before because the rules require it. Because we're making it very general, and the specific case requires more data. And so the property pattern is, how do we allow objects to add state to them at runtime? Python people are going, huh? What's the problem, right? Because that happens all the time, right? Python, you can anytime you can stuff more data into an object, and it's like, okay, fine. You just, and JavaScript is the same thing, but how do you do that in Java? A little bit harder. Well, property is just a value, right? And indeed, even in Java, what's a field in Java? This is a key and a value, right? The key is actually the name of the field you give in your source code, and the value it has at runtime. Right? In Python, Perl, they make that very concrete, right? I mean, literally, how do you store fields or properties in Python object? Anyone? All the Python people are really quiet. There's no Python experts in the class? How does Python store your fields?
I think each class is a dictionary, so you put some in a dictionary.
Yeah, it's a dictionary, right? And that's why at one time you can add more properties, just add to a dictionary. Foo.bar equals 5. And foo didn't exist in bar before, now it exists, right? It's a dictionary, right? It's also why Python consumes more memory, right? Because in Java, you compile it into, you have 5 fields, right? So there's that object in its memory location only leaves those 5 slots. In Python, you need that for a dictionary, and so how do you get with the dictionary? It has to be able to be configured. And so yeah, we can use a dictionary in Java. And then there's various methods you might want to know, right? I mean, if we're adding properties, the problem becomes how do you know if the property exists or not, right? And be able to set it and get it. And you have to worry about what policy you want to use. What happens when you try and get a property that doesn't exist yet? What should happen? What does Python do in that case? Is that a statement or a question?
Either gives you back no or it throws an exception.
Yeah, I mean, those are 2 options, right? So which one does it do? What's that? Value error? Right. So yeah, I mean, using this idea of property where there's a value and a key involves to add objects at runtime. I assume the Python people have done this. We've done any Python program at some point. It's like, okay, I need a new field there. So why don't you just add it? It gets more cumbersome, but I mean, is it there or not? Yeah, it's slower. Then the paper talked about this user-defiend product framework. And so the goal is to let users build up business objects. So again, basically you're creating a language, right? At a higher level, you're giving a bunch of small, low-level components that they can use to construct business logic. And so, yeah, it was actually used at an insurance company that allowed them to represent policies. And so, yeah, you have a bunch of different types of policies and different sub-pieces, right? So how do you, what's the best way of doing it? And so they don't use inheritance because inheritance becomes clumsy because it's fixed at compile time. You can't combine things very well. And so it's all done using composition. So you may have like a flood insurance and collision insurance or type of insurance, right? And you also, there's also homeowners insurance, auto insurance, but auto insurance may also have collision part and liability part, and we may need it tomorrow apparently. Flood insurance. Right, so a bunch of pieces in a composite so we can put them together to create a policy. So the composite pattern allows us to start down this road, here are the basic pieces we want, different types of policies, and combine them into a policy. Well, you've got collision for auto, liability, homeowner insurance, you've got flood, earthquake insurance, right? And the problem still is, right, you got a bunch of logic components. A new feature means adding a new component, which means you have to write the source code and compile it, right? It doesn't as flexible as you want. And then that component has lots of pieces to it, so how do we solve that? And so, just using what we talked about, right? Allow us to add properties or fields to classes at runtime instead of making instance variables or fields in Java. Right, so your policy needs a user and address, etc. Well, okay, we can just add attributes to the policy to do that. What attributes do you need? Well, often it's just their name and address and phone number, but then they might have more people insured than just one. Beneficiaries, different types of things that some people might have, others don't have. So we add those we can add those at runtime.
So with the pattern, I think I came across a pattern like this once, but I forget what it's called, but you have to have like meta classes, so you don't just willy-nilly throw properties on things. You'd have a meta class that said, okay, this is a auto insurance policy, and here are the fields that are in it. And then, when you create at runtime an instance of that class, there's no real class, but then okay, it needs these fields, and if someone else is trying to refer to it, it can go to that meta class and figure out, what's in it.
Yeah, and the question becomes, how do you find that meta class? Is it just a list of things that belong into the policy class? If so, that becomes data, right?
Yeah, that's right, yeah.
Yeah.
The meta class is data.
Yeah.
So instead of being compile time, it's, you
Right,
can do as many composites as
Right.
you want at runtime.
Yeah, for me, the term meta class is different meaning.
Yeah, I'm probably using the wrong one.
No, but in small talk, every class has a meta class, which defines what the class is. So meta class, I mean, just exactly what you said, right? The class has a name, and it has these end fields, right? So meta class specifies the fields the class has.
Yeah, and I was just talking about it being data
Right, yeah.
and probably loaded from a file or created at runtime.
Yeah, I mean, so that's this, right? Because now it becomes not compile time, but runtime. So we're pushing more of it down into data and less of it. Makes the code harder, right? Because now in Java, you don't have to worry about what the fields are. I mean, the compiler makes sure you know what the fields are, right?
So it's like reflection also holds some edit of a class.
Yeah, it depends on the language you're using, whether you can use reflection for this or not, right? But again, if you're just using a property class in Java, you can query the property class and know what the fields are.
So we can only query, we cannot add it through reflection.
Well,
At runtime, we can say add this method to this class.
in Java?
Yeah.
No, not in Java.
Through reflection, we can only get the data what it had. We cannot modify it.
No, Java, to do that, you need the compiler. And Java doesn't load the compiler at runtime. Python, yes, right. Lisp, yes. Yeah, some languages allow you to do that at runtime. Right, so we still have, methods. In the composite method, we need a way of actually putting the pieces together, growing the pieces. What is, we need information on the flood policy, right? Now here's where it starts to get really abstract. It's one thing to push which fields you have in a class for data, right? Because, okay, we can understand, okay, I'm going to read that, collision has these 5 properties, these are names, and we put the values, right? Now we can imagine writing code to read that file and then creating a property object with those keys, and then maybe having some automatic code generated to make sure that when you put something in that key, it's the right value, right? If food is supposed to be an integer in the property, we'll check to make sure it's only integers stored in there, right? Now it's like we want to suck the methods out of the class too. But we know the strategy pattern, right? And that's what the strategy does, right? We have some behavior that instead of being in a class, we put it in a strategy object, and then the class calls that strategy to do the work. Right? And so one of the things we want to do on a policy is you want to edit the policy, right? You go to the customer and you're trying to figure out, what pieces they want, don't want. So it's put together a policy, and so now we just different types of strategies, reach operation we want to do. And that way we don't need the subclass, right? Composite.
So could you do that with like the template method, and then instead of actually deriving a class, you would just set a strategy for each? You know, the template method has certain classes or certain methods that need to be overridden. Instead of overriding them, you would just set a strategy here, strategy here, strategy here, strategy here, and it makes a match. Getting anything you wanted.
Yeah, so can we use a template method to do some of this, right? Yeah, so we have a method which instead of calling subclasses called strategies, right? And then instead of doing subclassing, you would then populate it with the different strategies that you need.
And then you can do that at runtime.
Right, at runtime. And so it's going more flexible, right? We have more flexibility. But it's also, as we add more and more flexibility, it gets a bit more abstract, right? To know what's going on. And you have to write more code to manage the code, right? Because now you need to solve the strategies, and we do something and of course at runtime when something goes wrong, it's really harder to debug, right? Because it's no longer this method in this class went wrong. It's like, well, we're in this class, but it has a field. We'll only get one field with the properties, and so we have to inspect the properties. And then we have a bunch of strategies. You can see the strategy we're doing.
I mean, you have to do more work in a situation like that. You have to do more work to make sure you can give meaningful error messages, because
Right.
you can't trust the
Right.
compiler to do it.
Right.
You can't trust the runtime environment to do it.
And you can't use a compiler to do type checking.
But that's where you just need a lot of metadata, so that
Right.
you know,
Some way.
frame of reference that this
Right.
is right and this is wrong.
But we may have gotten rid of the subclass and composite, etc., but now we're subclassing for strategies. Now we got all our strategy get subclassed. Right, so now we want to use the interpreter pattern, right, to create the strategies. We're even pushing more stuff to data, right? And now, once we create this little language that we can interpret, right, to create our strategies, we can read that from a file, right? So we can start changing behavior just by changing data.
Before I went that far, though, I would try to make the strategies more configurable.
Right.
Configurable, what properties they work on, you know, some settings
Right.
that they can do different things. Because once you go that far, you're pretty much commit, because now you're into that programming language world where
Right.
now your script writer's going, oh, I need this, I need case, I need
Yep.
throw, I need, you know. And now you pretty much have to mirror everything that languages have already done, because, you know, you kind of gone through the wormhole, and now you're kind of back at the beginning.
Yeah, and the only hope is that the domain is specific enough that you can sit down and create a reasonable language for that domain. And they did it, right? So, I mean, apparently, of course, it's an insurance company, it's a big insurance company, so they have money is not quite the same magnitude as for most of us, right?
And you said it was a visual language?
Actually, I don't know if it's visual or not. I'm getting this second opinion. I read the papers, right? But the people who read the papers, I don't know if they actually worked on the project or just read it. Knowing the authors, they may have actually worked on it. They did a lot of consulting. Right, so now I'm learning that program's becoming more and more like a compiler, right? Right, so now we're getting the same problem again, right? If you get duplication, how do you get rid of duplication, right? So, to go down the wormhole a little farther, right? Now we can give type information to each object, right? But that, again, is added at runtime. And so there's a special attribute for the name, the type. So literally now, I mean, the data is, the fields are data, right? We're writing the strategies as data, right? And the language interpreted, and then to add back in some sort of checking, right? We need types. So we're adding type information, but we're adding it as attributes.
And someone doesn't want to have to repeat the same attributes over and over and over again, so now they want subclassing.
Right. Right? Now we're looking at what do we do, right? I mean, it's finance, right? And insurance companies are regulated, so they've got rules they have to follow, right? There's both accounting rules and state and federal laws they have to follow. Now, the decorator, right, to make sure that decorators are different rules, make sure they're followed. So that, right, we start to see using patterns right, in a context to make something very, very, very flexible. It's not a system I would think that most people would come up with right away. Of course, I don't know what happened to the system, right? It was a live system, they used it. I don't know if it's still in use today or not. And so this is probably a good stopping point.